Okay, I intend on working through these homework examples, or these examples of building these polynomials fairly quickly, because I really would like to get through all of them and make this the last video of the section. So we're asked to find the Maclaurin polynomial p sub 10 for our function f of x equals cosine x. So we're going to need the first 10 derivatives. And again, we show them in x. So I'm going to show those very quickly. I know that in the last example that I wrote down the general formula for the seventh order polynomial. We don't have to do that. I did that just for teaching reasons. The only thing we have to do here is just take off and show our derivatives. I do want the derivatives shown in x. I hope I'm taking all these right while I'm talking. You guys can double check me. So I want them shown in x first. That's not only for the AP reader's benefit, it's for your benefit as well. There's the first 7. I'm going to jump over here and leave some space, and I'm doing that on purpose because this is how the work should actually look. All right, so let's see. We should go cosine, negative, cosine, sine, cosine, negative, sine, cosine, negative. OK, so all those are right. So then what I usually do is just go out beside those, and so it doesn't take a whole lot of time, and show my work where I'm evaluating that derivative at that center point of tangency, and here it's 0. So these are going to be relatively easy to evaluate, but you still need to show this work. Fourth derivative at 0, positive 1. Fifth derivative at 0 is 0. I'm just plugging 0 into all of these derivative functions and evaluating them and showing my work that 8th derivative at 0, positive 1. 9th derivative at 0 is 0. 10th derivative at 0, negative 1. So fairly quick. All right, so p sub 10 of x is the output of the function at a. That's 1. And then f prime of a times x minus a, well, that coefficient is 0. F double prime, so minus 1 over 2 factorial times x minus a squared. Well, a is 0. No third term. Fourth term plus 1 over 4 factorial x minus a, where a is 0, x to the 4th. No fifth term. Sixth term, minus 1 over 6 factorial times x to the 6th. No seventh term. Eighth term, plus 1 over 8 factorial, x to the 8th. No ninth term. 10th term, minus 1 over 10 factorial, x to the 10th. So we would normally write it like so. X to the 4th over 4 factorial plus x to the 6th over 6 factorial, sorry, that should be a minus, plus x to the 8th over 8 factorial minus x to the 10th over 10 factorial. So there's p sub 10. So not a lot of work to do, not super time consuming. However, when you build it from scratch, there is a lot of work to show. So you have to show all of that work when you're building your polynomials from scratch. Really quickly, here are p sub 1, p sub 2, 4, 6, 8, 10. The red function is the cosine function. Here's f of x. Here's our linear function. P sub 1 is just the horizontal line, x equals 1. P sub 2 or I should say P naught, sorry about that. P sub 2 is a parabola that opens down, translated 1 unit above the point of origin. So this is the parabola that opens down. The further and further and further we get away from x equals 0, the more and more terms we're going to need for our polynomials to act like the cosine function. Same kind of idea that we had with sine. Find the first 4 terms in the Maclaurin polynomial for this function. Well, with Maclaurin, they've told us something. They told us we're building around x equals 0. So we need our function, which they give to us. I'm going to rewrite it so it's easier to take the derivative. So negative 1/2 4 minus x to the negative 3/2 times negative 1. Please don't forget your chain rule. Second derivative, positive 3/4 4 minus x to the negative 5/2 times negative 1. Chain rule. Let's see, negative never makes that positive. That's actually going to be a negative. Sorry about that. So now this is actually a positive. Negative and negative makes a positive. So third derivative. So that negative comes down with that positive, and that makes that a negative 15/8 4 minus x to the negative 7/2 times negative 1. Now that coefficient is a positive. Fourth derivative is whatever in the world 7 times, or negative 7 times 15 is, over 16. 4 minus x to the negative 9/2, again, chain rule says times negative 1. So this, whatever that value is a positive. So we're going to find p sub 4 of x. It is the output of the function. Let's go back here and evaluate them all at 0. F of 0 is 1 over the square roots of 4, so that's 1/2. F prime of 0 is positive 1/2 times 1 over 4 cubed and the square root of that. Second derivative at 0, this becomes a positive 3/4 times 1 over 4 to the 5th and the square root of that. Third derivative at 0, 15/8 1 over 4 to the 7th and the square root of that. Fourth derivative at 0, 15 times 7 over 16, 1 over the square root of 4 to the 9th. So there's our coefficients, and we can put those in there. We'll have 1/2, that's f of 0, plus 1/2 times 1 over the square root of 4 cubed, all over 2 factorial times x minus 0, right? I have to remember, sorry, that's 1 factorial. I have to remember to put my factorials in there. It is over 1 factorial. We haven't really covered that before. 1 factorial is just 1. That's usually why we don't write that in there. Plus 3/4, 1 over the square root of 4 to the 5th. Sorry, that's over 2 factorial times x squared. I'm trying to hurry because we have one more example, and I really want to get it done in this video. If you have questions, then we could go from there. All of that, this is the third derivative, goes over 3 factorial, x minus 0 cubed. And finally, 15 times 7, all over 16, 1 over the square root of 4 to the 9th. That's my fourth derivative, all over 4 factorial, x minus 0 to the 4th. So there's p sub 4. So I think we can at least get started here on this last one. First 4 terms of the Taylor polynomial built around x equal 2. So f prime of x, 1 over x plus 1, could also be written as x plus 1 to the negative 1 for taking derivative purposes. Second derivative, negative pops down front, reduce it by 1. Third derivative, negative 2 pops down front, reduce it by 1. And fourth derivative, negative 3 pops down front, reduce it by 1. Let's evaluate it at x equal 2. We need f of 2, which is the natural log of 3, f prime of 2, which is 1/3, f double prime at 2, which is negative 1 over 3 squared, or negative 1/9. F triple prime at 2 is 2 over 3 cubed, or 27th. Fourth derivative at 2, negative 6 over 3 to the 4th, 3, 6, whatever 3 to the 4th is. Can't go there. All right, so really quickly, p sub 4 of x, natural log of 3, plus 1/3 times x minus 2, minus 1/9 over 2 factorial, times x minus 2 squared. If I get cut off, you get the idea. 2/27 over 3 factorial, x minus 2 cubed, and so on. All right, come next time, we'll do some homework problems.